Assalamu alaikum, welcome to Qamar MoonBoy channel, and this is a new video for you. Do like my video so that I can create more for you by clicking on this like button, and also subscribe my channel if you haven't subscribed my channel till now, and also press on the bell icon if you're not getting this notification for my channel. You will get a notification every time I upload a new video. Thank you.
Assalamu alaikum. Welcome to the ETABS tutorial, and in the previous tutorial we have designed as per static method of analysis. Now we will do the dynamic method of analysis. As per our code, you can see here we have two methods of analysis. So while doing the dynamic analysis, during the structural data we are giving, we have given the for columns 0.7, that is a percent of I. We have taken the coefficients, right? So the column coefficients and the beam coefficients. So here all it is given, say 70% and 30%, 35% for beams. So whatever we have taken is correct, and for steel it is 1. So steel it is 100% we have to take. So these are nothing but the modifiers. So what we have considered: stiffness and property modifiers, I value, moment of inertia value we have given. Okay, so this shall be considered for actually for doing the seismic analysis. So this is given in the seismic code, you can check. So now we are going to do the response spectrum analysis. In this response spectrum analysis, you can see dynamic analysis can be performed in three ways, namely response spectrum method, model time history method, and time history method. You have to check, see, equivalent static method may be adopted. So what method we have considered, that is only for the TA period is less than 0.4 seconds. You have this formula 0.075 into h power 0.75 for this MRF type of building. So this formula, with this formula you will get if the time period is 0.4 and less, then only you can use equivalent static method. Otherwise you have to do the dynamic static method, dynamic analysis. That is you have to go for response spectrum, or you have to do time history analysis. So let us do response spectrum method. So first we have to unlock the model. Here are the base reactions for our general analysis. Now we will unlock the model. So I have unlocked the model, and I can just close this one. Okay, now I will go to define. We will check the diaphragm is correct or not. Okay, it is a rigid diaphragm, keeping a rigid diaphragm, and mass source, everything is to be perfect. Okay, so these are the setup. Once again you need to do, or if you have not done previously, you are doing directly the analysis, so you have to set up this or check these cases also. So now, as we have seen all this data, now we have to form two load cases for response spectrum. In that we have to use the function of response spectrum. So as you know, which is this is the building we are designing for the zone 5 region. So you have to consider the zone 5 function. So you have to go to functions in the defined, you have to go to response spectrum. Here already one function is there, that is unit function of a response spectrum. So that is based on ASC code. So we have to select one code here, that is our code IS 1893 2016. You select it and press on add a new function. So in this we have added a new function. Let us name it as response spectrum as per Indian standard. Okay, function name, we can keep anything. And the function damping ratio, that this we have to consider based on the codal provision. Basically we take 5%, and for concrete building, let us see what the code says for the damping ratio. Here is the damping ratio 7.2.4. The value of the damping shall be taken as 5%, and critical damping for the purpose of estimating AH in the design lateral force VB of the building as per 7.2.1. Okay, we will see what is 7.2.1. Irrespective of the material of a construction, namely steel, reinforced concrete or masonry, a combination of thereof of these three basic materials of its lateral load resisting system. So any kind of building, firstly you have to take the damping ratio to be 5%. So this value of damping shall be used irrespective of the method of the structural analysis. Whatever be the method you are doing, a static method or dynamic method, you have to take 5%. Okay, so these are the different method, that is 7 point as per, that is equivalent method as per 7.6, and dynamic analysis method as per 7.7. 7.2.1 design lateral force. The building shall be designed for the design lateral force VB. VB is equals to AH into W, whereas AH is the horizontal force that comes as per the W. Okay, so that we know, that is nothing but the base shear. So in dynamic analysis you have again here, this we will see in the forward. So let us based on that damping ratio, we have to take 0.05, that is 5%. We know the seismic zone is 5, so zone factor will be automatically taken, that is 0.36 for zone 5, and the importance factor we know it is 1.2. in the previous video we have shown, and the soil type we have taken 3, so that also we have and you know that response reduction factor you have to take 5. These are all values we are taking from the code book only directly. So in the previous video I have shown how to take from the code book. So during the earthquake loading, mentioning the earthquake loads, so this is nothing but our curve. So this is the curve we obtained based on the data we have given. So this curve is also given in the code book. You can see this is the curve. So this curve based on the different type of soil, 2B spectra curve, 2A spectra curve, here it is mentioned corresponding to 5% damping. So this is taken based on 5% damping only. So our curve is correct based on that. So click on OK. So we can delete this previous spectrum. Click on delete spectrum, and only our response spectrum based on IS, that is Indian standard, is remaining. So this one we will click on OK. So you can save it. So let's see the response spectrum. Now we have to define the response spectrum load cases. These are load cases, not load patterns. So let us define it. So we will define in the two directions, that is response spectrum X and response spectrum Y. Okay. We'll press on add new case. Here we will write response spectrum name, that is RSX. We'll take it is as a response spectrum. Design we will keep program determined, and mass source will be mass source 1. Here model combination method is CQC, and direction combination method is SRSS. So As mentioned, CQC and SRSS has been given in the codebook, and SRSS is the best combination method for directional, and if it has the 10% variation of the combinations. So now we'll keep these same, and the model damping is 5%. We can change by clicking on this. Okay, and we can also change the eccentricity of the diaphragms. So now we will add the load direction, that is we will add the function. Click on add. Here we will select the acceleration. Here the direction is u1. The function will be not default, but we have defined that RSIS as a function, so we will take that one. And scale factor, it is given as that is gravity, that is 9806.65 is nothing but the g value, gravity value. So that value will change to our Indian standard value. So as per ETABS, the scale factor in response spectrum analysis should be taken as response spectrum scale factor is Ig by R, where G is the acceleration due to gravity, and that value should be 9.81. But here you see the value in our ETABS is 9806.65, that is 9.81 only. Why it has taken multiplied by 1000 is, if you go to units, okay, so if I have to close this, right? So I'll press on OK, and I'll just go to units, and I'll show you here. We have to close this also. Click on OK, so that the load should not get deleted. We'll go to units. Here you can see in units, right? In units you can see the acceleration due to gravity, right? The acceleration is mm per second square. So but our acceleration due to gravity is meters per second square, so we are converting that meters to mm. That's why we are multiplying with 1000. So let us go back to the load cases, response spectrum, modify. Okay, so this is the scale factor, that is G has been taken, but we have to take scale factor as per ETABS and as per IS code. So in this you can see Ig by R is the scale factor we have to assume initially, but it is as per SCE code. But for Indian code, I have to go to this scale factor for IS 1893 Indian code. If I go to that, I'll find that here in the design spectrum we have to actually take, see, then first in the first run we have to take the scale factor value SF is equals to Ig by 2R. So here in place of R we have to take 2R. So Ig by 2R will be, if I calculate Ig by 2R, okay, so I we have 1.2 into G we have 9806, right? 9806.65 if I take, right? Okay, if I take that one, this is Ig is over, divided by 2R. R value is 5, so divided by 10, divided by 10. So 1176.798, right? This will be the value. So I will put this value in the scale factor, right? Similarly, we have to take the scale factor and we have to take in the y direction. So add a copy of this, name it as response spectrum Y, and you change the direction to U2, and the scale factor will be same in both direction. And U3 direction is not required because response spectrum for Z direction is not there. Okay, so whatever you take in the Z direction, that will not come, the value will be 0. If you want to try, you can try, and you have to again further come back and delete. So I have tried it already, so I am telling you, if you want to try, take in the Z direction also U3, you will get response spectrum to be 0. You will get earthquake forces, but response spectrum value will be 0, right? So we have defined two response spectrums. Click on OK. Now you have to analyze the structure. You have to run each and every case. So until the analysis goes on, let me show you the combination of modes. Here in the code book, it is mentioned the combination of modes, that is CQC, is nothing but complete quadratic combination. This is the formula, and another is SRSS. That is also mentioned here somewhere here itself. Okay, square root of the sum of the squares. This is SRSS. Okay. After analysis, we have to check that V bar by VB. Okay, VB bar by VB, that is base shear. Okay, from the TA, and TA has to be taken from 7.6.2, and as I told you, for our building, that TA has to be considered from the analysis of our building static analysis, what we have did, and the linear static earthquake forces, from that, what is the base shear we have developed, that we have to come do, and we have to find this scale factor, so we have to multiply based on this. So here we have this VB bar by VBX. It is VB bar is the base shear found from TA, but we know that we should not use this TA, we should use the time period and the VB of EQX, what we have found in the earthquake analysis, and we have to multiply by 85% of the static base shear divided by the response spectrum base shear. If the value of response spectrum base shear is less than the static, then only we have to multiply with this scale factor, and Ig by 2R is already there, so let's find it. Okay, so in place of Ig by R, we have to place Ig by 2R. That's all. So let's see our ETABS model. So here analysis is over. Just let's go to the display, show tables. Okay, select all. Okay, and then go to the base reactions. Okay, so we have EQX, EQY, EQZ. Then then RSX max, C, and EQXY, and this. So you have base shear less than that of EQX and EQY, right? So we have these values, so write down these values and note it down. Okay, so we have to Now do the scale factor. We have to divide this divided by this into Ig by 2R into 85%. So we will take 85%. So we will multiply and then as per the code book, if you use TA, then we have TAX formula. From that we have to find AHX, then we have to find SFX and SFY to from the AHX. From that we will get VB is equals to AHX into W. So that is the procedure of IS code where TA is used, but we are using the direct base shear. Okay, we are using the direct base shear, which is here, right? And so we will divide this by this, so to get the SFX. So SFX we will write here, we'll get SFX is nothing but, okay, this multiplied by this value will be there always, so this multiplied by, okay, you copy this, okay, copy this, keep it here, Ig by 2R, paste this value will be here. Okay, so Ig by 2R is there. Okay, so we will divide this, right? Okay, divided by this value. This is the value 6.322. okay, that multiplied by, you can take 85% or you can take 100%, but as we are taking not the TA value, we have to take 85%, so we will take 85% of the response into 0.85 equal this value. We will multiply this value with Ig by 2R, that is 1176.798. okay, similarly this is the value 6324.585 or 586 we will keep, so keep it here. Okay, so similarly find in the opposite direction. So we will unlock the model and we will paste this scale factor values in the response spectrum X and response spectrum Y. Okay, so let us go to the scale factor. We will unlock the model. And here we have the load cases in this response spectrum. Go to modify. For X direction, scale factor is now this one. Let's check it again. Yes, okay, it is taking the roundoff value. For Y we will take the scale factor, this one. Okay, so now the base shear should be 85% of that base shear, so that will be, go to the analyze, after analysis we will get that. Okay, So if I check the base shear after analysis, it should be 85%. And so from this analysis, you will see the responses of the building. What is the maximum deflection coming from the response spectrum and all we will find. So those are within the limit or not, and the time period of the building in the first response, second response, third response, that. Okay, so all these things you have to see, right? So let us just go to the base reactions. Here it is not showing, right? So you have to go to display, show tables option, you have to select all, now it will come base reactions. I can see EQX is nearly, this is 85%, so EQX and RSX is 85%. So this is how you are doing the response spectrum analysis, and this response spectrum analysis is nothing but the actual response spectrum analysis based on IS code. So everything we have taken based on IS code, and the results you can see after this is nothing but, you can go to display, we can see there is story response plots. Here in the story response plots, you select here the load case type to be response spectrum X, and after this in the you have to mention this as a ground floor to be your actual story. Then the curve will start from here actually. So the curve is starting from the foundation, so we have to actually, while mentioning the building itself, we have to mention that the base story is this one. So that is in the edit grid data. Okay, grid systems, here ground floor should be your 0 level floor. Okay, so you can see here actually you need to mention, okay, the elevation to be here, it should come 0 and this should come below, that is minus levels of the ground, right? So at the time it will come the proper curve. Okay, so similarly you can see for the RXY, that is we are seeing the maximum story displacement. Here it is mentioned the maximum story displacement. These values 23.707. So that is in mm. So 23 mm is the maximum displacement. So it is underallowable. So we can manage. Okay, we can manage this. We can use. So the responses are within the limit. So similarly, what you can see is, you can see the story drifts. You can go to maximum story drifts. Okay, due to response spectrum X, and the maximum story is, it should be less than 0.04%. so 0.001 it is maximum, so the drift is very less. If you can go to the shears, story shear, you can see the shear forces. So this is the shear force, what you are getting here is in the graph now. Okay, so that you can distribute over the floors, overturning moments, and also you can see the stiffnesses. So these are the different this is the first structure, it will go very high, then it will come down. So the maximum stiffness is this one. So that is in the base flow, maximum stiffness required. Based on that you have to design the columns of the base. Okay, so next you have the auto lateral loads. You can see these are the lateral loads due to EQX. Okay, here you can see EQX and EQY loads of auto lateral loads in the stories. Okay, so these are the different loads acting in the different stories. So what more, you can generate this, you can take this data outside, using this summary report or detailed report of this each and every curve like this. And you can also save and print this data, all the data you are getting here. You can go to model analysis response. You have seen what you can take mass ratios and all. Okay, in the tabular form you can take from the below. You can just copy this data, total data. You can just copy and paste in the Excel sheet. So you can save it in the Excel sheet. You can just take it out as a export to the Excel. Okay, so that options is also available here. So this is the end of this response spectrum tutorial. In the next video we will see the time history analysis, so stay tuned to our channel, and we will do based on the Indian time history earthquakes. Okay, we will take some nice and huge magnitudes earthquakes occurred India or nearby India to analyze our building in time history analysis. So thank you for watching this video and making up to the end. Do like, share and subscribe my channel and this video. Thank you. Have a nice day.